All right, welcome back. Your lesson tonight is moving us into topic 9. Now you have learned how to add fractions that have the same denominators on the bottom. You now have mastered adding fractions where the denominators are different. So our next natural step is to start adding numbers that are mixed. And I don't know if you remember for fourth grade, a mixed number is a number like 2 and 1/4. Can you tell me why you think it's mixed? Yes, exactly. I hope that you said that it's mixed because it has a whole number and has a fraction. Therefore, the name mixed because it contains two different things. All right? So we have to have this lesson before we get into adding those types of numbers because you will come across the term improper fraction. And really, an improper fraction is a mixed number. And I'm going to demonstrate them in just a minute to show you how they're exactly the same. But in order to do that, you have to know what an improper fraction looks like. An improper fraction has an enormous, or not, it doesn't have to be enormous, but the number, the numerator on the top, is larger than the number on the bottom. Just as a reminder, this number on top is the numerator. And normally it is not larger than the denominator, but sometimes it is, and therefore it's called improper. It's kind of weird. Things that are improper are not normal. So whenever you get an answer where the numerator, this number, is larger than this number, we want to change it to its mixed number equivalent. And it's really easy to do, but first let me demonstrate how these two numbers, though they don't look the same, are the same. Okay, I'm actually going to start with the improper fraction because it's a little bit easier to, well, it's not any easier to draw, but you'll see what I mean in a minute. Remember that the denominator is the number that your whatever you're talking about is broken into. So this says 4, so that means I'm going to take my pizza, okay, or my candy bar, and I'm going to break it into fourths. So the number on the bottom tells me the size of my slice. Okay, now remember that the number on the top tells me how many slices I have. Now look at this. Notice that if I were to shade this in, let me use a different color here. If I were to shade this in, I can only shade 4 at a time because I only have one hole showing there. But I have 9 pieces. So what do you think I'm supposed to do? Exactly. I'm going to draw another pizza pie. And guess what I'm going to cut it into? Remember, the bottom number tells us what size pieces. So I'm going to cut that in fourths too. And I'm going to shade that in. And when I do, now how many total fourths do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. I still don't have the number on the top. So what do you think I do now? Exactly. I am going to draw, whoops, that should be blue, shouldn't it? Let's erase real quick. Go with the blue. And we're going to draw our pizza. So I've already shaded in 8. I only need to shade in how many more now to represent the fraction, the improper fraction on the top. Exactly, see? So if you count up the number of holes, I have 1, 2, and a fourth here. But let's count up the number shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9. So sure enough, I am representing the improper fraction with the diagram below. Now, if I wanted to show this, the mixed number, the 2 tells me I have 2 whole pizzas. Do I need to cut them? I don't have to, so I'm going to go ahead and just shade them in because I know I have these complete. That's what that whole number tells me. And then I have in a little bit more. So if I do this, now this fraction, remember, it's cut into fourths. That's the number on the bottom. And I have 1, so therefore I'm going to shade in 1. And I want you to see, aren't these pictures basically identical? I have in my mixed number my 2 holes, and my quarter, so that represents 2 1/4. And then over here, I have 9 shaded fourths, but if you look at the picture, it again is 2 fourths, or 2 wholes, one here and one here, plus a fourth. So really, these mean the same thing. Also, what if I went back and I did this, and I cut these into fourths? Now, look at my picture. Now they're the same. So essentially, 2 1/4 is equivalent to 9/4. And now, the other thing I want you to note is, you guys are used to having fractions that are smaller than 1. But we now know that fractions can be larger than 1. We can have more than one full thing shaded in. This is an example. We actually have 2 things shaded in with a fourth. Alright, so let me show you a shortcut. First, we're going to do our cheater with the improper fraction. And we'll do it over here. Our cheater, to make our life, instead of having to draw it every time and figure out what the whole number or mixed number equivalent would be, here's my cheater. It's called the backflip. That's why I have a picture of the backflip guy. So our cheater is called backflip, and basically we backflip the number 9/4. It's going to backflip like this into my house, and the 4 is going to go right there. Alright, how many times is 4 going to go into 9? It's going to go in twice. So you're going to have to dig back to your division that we learned at the beginning of the year. So we go now, 2 times 4 is 8. We subtract. We notice that there are no more numbers, but we do have a remainder. So the way that we write this is we've got our 2 as a big, huge number. We take our remainder of 1 and we put it over the divisor, or the which was already the denominator when we started with. The denominator doesn't change. So if you start off with a 4 before you do the backflip, you're going to use a 4 in your final answer when it's a mixed number. Alright, and I'm going to give you another example in just a minute, but basically all you do is divide the top number by the bottom number and write the remainder as a fraction. For the cheater, for going the other way, because these are interchangeable, you can always check these to see if you've done it right. We call it a cartwheel. And basically what you're going to do is, you have your number, which is 2 1/4. Okay, we're going to cartwheel this direction. You're going to multiply first, and then you're going to add. Multiply, add, meaning I'm going to multiply 4 times 2, and then I'm going to add 1. Okay, and that's going to add up to 9. Now, the 9, therefore, is what's going to be your new numerator, and your denominator, which was 4 to start off with, stays 4. Just like when we were working with our backflip, okay, notice that our numerator here, or excuse me, my denominator started off as 4, and in my fraction it ended up being 4. Just like I started with my mixed number over here and converted it to my improper fraction, the 4 stays. So whatever denominator is there is the one that you use. Alright, here's another example. Okay, I've written a number here. It is a fraction, but notice this is a weird fraction. It's not a mixed number because there's no whole number in sight. So it has to be our improper fraction. I know it's improper because the number on the top there, the numerator, is way bigger than the denominator. So I have to remember I'm going to do my backflip cheater. And to do that, we simply, remember this backflips into the house. So I'm going to put 11 here. And what goes over here in this spot? Exactly, the other number, 3. So once you remember to put the 11 in the house and put the 3 on the outside, then you're good. How many times is 3 going to go into 11? Exactly, it's going to go in 3 times. 3 times 3 is 9. Okay, I subtract, I get 2. There are no more numbers over here, so therefore I'm going to write my remainder as a fraction. Use my big 3, because that's my whole number. I'm going to take, that comes from, let me highlight here so that you see, I took my 3, this 3 goes right there, okay, as the whole number, and then I'm going to write my remainder over the divisor, which just happens to be the denominator. The denominator started off as a 3 and has to end as a 3. All right, so 11 thirds is the same as 3 whole pizzas and 2 pieces left over. If I were to draw a picture, I'm going to pause to draw it so you can see what that looks like. Okay, I just went ahead and drew 3 pizzas, and the denominator here was 3, so that means that's what I cut my slices into, thirds. And I know it's definitely going to be more than 1, so that's why I drew 3 of them. All right, and then now I'm going to shade, and I'm going to use the improper fraction. How many of these do I need to shade if I'm using this improper fraction? Exactly, 11. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't draw enough pizzas. I've got to draw another one because I need to have 11 shaded pieces. All right, so are we ready to shade this last one? That's 10 and 11. So let's look at our mixed number that we came up with when we did our backflip. We had 3 holes. Oh, check, check, check. And now let's look at our fraction, 2 thirds. Check. Okay. Now, let's see if we can check this answer by doing our cartwheel. We should be able to do the backflip and the cartwheel and end up with the same numbers. All right. 3 and 2 thirds was the answer that we got over here. Let's check to make sure that we can get back to our improper fraction. Our cartwheel goes around this way with times, and then goes around this way with addition. So we are going to multiply 3 times 3, and then we're going to add 2 to that. If you did that math, which is pretty easy, that's 9 plus 2 more is 11. We take that 11 and we put it over our denominator that we started out with, and we started out with 3. So therefore 3 is what gets written here in the bottom. And sure enough, look at that, like magic. 11 thirds was what we started off with here, and 11 thirds is what we get. So you should never get these wrong. You can always do the reverse, either the backflip or the cartwheel, to go back and forth, because these things mean exactly the same thing. They're equivalent. All right, go ahead and print the notes and then answer the questions to show so you can get credit for watching this video today. Good night.